So we were looking at a continuous variable, right? Before, a single continuous variable, for example, loan size here. Now we're going to start looking at a categorical variable, right? And categorical, we know, right? It's a variable where you don't have integers. It's basically a category. Okay. We're going to look at loan grade. Loan grade is a column in our data set, and okay, loan grade is A to E or whatever it is, right? Or maybe AAA is also in there. A single categorical variable, right? So you do a count plot of the loan grade, and you can define an order, okay? And you want from AAA to all the way to E, and you do that, and you can see that the highest number of loans in this data set are with the loan grade B. The smallest count is for AAA, okay? You can also define custom colors if you want, if you don't like the colors and all. So you know that's where you can spend a lot of time, trying to make your plots very, very pretty. And I like to do that personally. So we are defining this palette of colors called upstart colors, and we are assigning this upstart colors to this thing in the count plot called palette. Assigning it to palette, and you can sort of change the colors, okay? You can also discretize, okay? So you can we're going to go back to the loan size, okay? I think we talked about we can turn a numerical variable into an ordinal one through one of the two functions. So we can sort of turn, and we know what an ordinal is. Ordinal is highest to lowest, right? So you have some kind of an order, right? Let's create a copy, and let's create a new column, okay, called discretized loan size, and we're going to cut the loan size, and let's see, we're going to cut it in 5 bands, I believe, okay. Yeah, 1, 2, 3, 4, and 5 bands, okay, and these are the categories, okay, because we specified a number 5, and we are going to look at the count plot, okay. So you can see we created this this numerical variable called loan size into a discretized, sort of like a categorical, but now it has some kind of an order, right? It starts low and then goes down, okay. So you can see that the range which is close to $50,000 has a very small count. The lower end of that dollar number is a high count, okay. You can see that you cannot see some of this labels on the axis, right? So you can change the size of the figure, okay, and here we are going to change the size of the figure by defining a figure size before that, and we are adding the same code, and you can see now clearly as to what these ranges are, okay. So this is discretizing equal width binning, because the width is now equal, right? It starts at one point, ends at another point, starts at one point, ends at another point, and so and so. You can also say equal frequency binning, right? So if you want to have the same count, what kind of so we're going to make a copy again, same number of 5 steps, and we're going to do equal frequency, right? So PD cut is going to do equal frequency, PD cut is going to do equal bin size, okay. And you'll see what I mean by that. So equal frequency means this thing is varying, but the count is almost the same, right? So you see 11,600. So this gap is different than this gap, is different than I think this gap, this gap, this gap, and it's trying to do the same number of count in the same in all the bars, okay, in all the different splits. So just a different way to look at the data, right? If you wanted to bin them, a continuous variable, you can do that, okay.